welcome to True Projects. In this video, we will be explaining about optimizing the performance of the data warehouse by query cache mechanism. Introduction. The project emphasizes the significance of data warehouse in a variety of commercial and internet applications that rely on handling customer data. However, retrieving data from the data warehouse might be time consuming, resulting in customer response delays. To address this issue, the project suggests using query cache methods which store and retrieve query results in order to minimize search time. Existing cache algorithms such as OLAP, LRU, and size have memory use and execution time restrictions. To address these constraints, the project presents a novel technique known as LFU with size, least frequency used combined with size, to reduce execution time and enhance cache efficiency. This strategy takes into the account age, frequency, and memory usage of cache query results. Objective. The project's goal is to improve data warehouse and speed by successfully managing the query cache with the LFU with size approach. This major goal is to reduce reaction times in applications that rely significantly on data warehouse for customer data management, such as e-commerce, banking, and social networks. The project intends to overcome the shortcomings of existing cache algorithms and improve cache management by taking into account of age, frequency, and memory consumption of cache query results by introducing LFU with size approach. Through simulations, the project proposes to evaluate performance of LFU with size with that of alternative cache techniques such as OLAP and LRU. The ultimate goal is to demonstrate LFU with size usefulness in reducing execution time and decreasing cache memory utilization. These are the requirements for execution. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDE of 3.7 version is required. We have used these algorithms for execution. First one is LRU, which is least recently used. LRU is another existing cache technique used in this project. It starts inspecting the cache upon receiving a new data request and removes the least recently used query results to make space for new queries. However, it may not effectively handle cache overload and doesn't consider query result age and size, leading to increased execution time. Next one is SIZT, which is size. It is another existing cache optimization algorithm used in the project. Upon receiving new request data, it looks for and deletes object taking up high memory in the cache to make space for new query objects. However, iterating through the entire cache without considering age and frequency, it can consume more execution time. Third one is LFU with size, which is least frequency used combined with the size. This is a proposed novel technique introduced in this project. It considers age, frequency, and size of cached query results. It finds query results objects with the lowest age and frequency and removes those consuming high memory based on the requested data MB. By employing age, frequency, and size, this technique aims to reduce cache iteration and result in less execution time and proper cache management with high frequency and age records. These are the design modules for execution. First one is generate simulation data. Using this module, we will generate some cache data randomly. Next one is run LRU technique. Using this module, we will optimize cache with LRU technique and capture execution time. Next one is run SIZT technique. Using this module, we will optimize cache with size technique and capture execution time. Next one is run propose LFU with size technique. Using this module, we will optimize cache with propose LFU with size technique and capture execution time. Last module is execution time graph. Using this module, we will plot comparison graph between all the algorithms. For execution, first open the code folder. These two are the Python main code files and this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. Double click on it for execution. This is the graphical user interface of the project. With this, we can interact with the program. This is created using Tkinter library in the Python. So here, In text field, we need to enter some requested or require MB of the data to store in cache, and then click on generate simulation data to generate some cache values. So here I will be entering 200 and click on generate simulation data. It has generated some cache, age and frequency. Now click on run LRU technique to optimize this cache. So here it has given the execution time and it has given space to new objects. Now click on the button run size technique to optimize the cache. So for this algorithm, this is the execution time and these are the new object space allocated to it. Now click on the button run propose LFU plus size technique. Here is the execution time of the proposed algorithm and this is the space allocated for new objects. Now click on the button execution time graph. Here x-axis represents the technique names and y-axis represents time, and in all techniques proposed LFU with size has executed in less time. So close this, exit the graphical user interface. Conclusion: the project emphasizes the usefulness of the proposed LFU with size, which is least frequently used combined with size technique in optimizing warehouse performance by controlling the query cache. The project goal is to improve cache efficiency and reduce response times of various business and web applications that rely on data retrieval from the data warehouse. The project illustrated that LFU with size provided superior execution time and proper cache management through simulations and comparisons with existing cache approaches like OLAP and LRU. LFU with size optimizes cache iteration by taking into account the age, frequency and size of cached query results, resulting in speeder execution time and efficient memory consumption. The findings of the project indicate that LFU with size can efficiently minimize the time and resource necessarily.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.